we're back. So now to active transport. We just talked about passive. Remember, active requires energy. If you're going to be active, you need energy. And this is going against the concentration gradient. So things don't go from low concentration into high concentration normally. That's just not the way things work. So to go against the concentration gradient, you need energy. And I like to think of a boat sitting in a lake. So the lake has a high concentration of water. The boat has a low concentration of water. If you get a hole in that boat, naturally, it's going to go from high concentration in the lake to low concentration in the boat. It's going to start flooding your boat. To get that water from the low concentration in the boat back to the high concentration in the lake, you're going to need an energy pump. So that's how we think of active transport. It shows the difference between the three. The only thing I don't like about the picture is in diffusion, those particles should be a lot tinier because they've got to be so tiny that they can easily pass through like gases, CO2 and O2. Facilitated diffusion is facilitated with a protein, still goes high to low, and then active transport is a pump that uses energy and it goes low to high. All right, channel proteins. These allow charged ions to go through to move with a concentration gradient. They are specific to an ion. And there we've got examples of channels. Now, the phospholipid tails are hydrophobic, so they don't like charged particles. So charged particles do need a channel protein to get past. Finally, the sodium-potassium pump. Let's look at picture number 1. We have it's pumping sodium outside of the cell and potassium inside of the cell. And it's got a spot for 3 sodium ions that fit its shape, the shape of the sodium ions perfectly. So those sodium ions go bind into their shapes. And then, excuse me, guys, ATP here is the source of energy. When it donates a phosphate, it causes that pump to change shape, where it opens up to the outside. Now the sodiums can leave and the potassiums come in. And when the potassiums come in, the phosphate leaves again to go join ADP and it changes its shape again. So it pumps open and close, allowing it to do its thing. All right, guys, that's all I got for now, and we'll see you next time.